Okay, so this is assignment 4.5. Quantitative data refers to using numerical values that are collected. The benefit of using quantitative data analysis is that there is greater possibility for generalization to a population. You can involve a large number of subjects, and you can get a broader study because of this. As a researcher, we need to present the data in different ways, as well as forming a hypothesis or testing a hypothesis using this data. There are three different types of hypothesis, which include the null, single-tailed, and two-tailed hypothesis. A null hypothesis, according to Purnett 2016, states that an experimental factor is tested against a hypothesis of no effect or no relationship based on a given observation. This is saying that a null hypothesis is assuming that there is no significant outcome or relationship, and our research either accepts or our research either rejects the null hypothesis or fails to reject the null hypothesis. A two-tailed hypothesis, according to Salkind 2010, hypothesis does not specify whether the parameter is greater than or less than the value. This is saying that a two-tailed hypothesis believes there will be a significant outcome, but there is no explanation of the difference. The last hypothesis is a single-tailed. This hypothesis says that there will be a significant outcome, as well as explaining the difference. We use normative data in our research because it is national averages of these datasets. This means that we are able to compare statistics and results to national averages to gauge whether the results are above or below national averages. In this presentation, I will be explaining different ways of data presentation and different ways of data analysis. In this presentation, I always also talk about organizing data. There are multiple ways of organizing data, such as range, rank order, frequency, and grouped frequency distribution. According to Taylor 2019, the range is the difference between the maximum and minimum values of a dataset and serves as one of two important features of a dataset, and is one of the ways that data can be presented. The table shows a dataset that has been ordered into lowest and highest values for the results of people carrying out the standing vertical jump. The range is worked out by me taking the lowest value away from the largest value. As we can see on slide 1, figure 1 shows the original dataset that hasn't been ordered, and the second column is labeled ordered, where I've rank ordered the dataset. In figure 1 we can also see that rank order. This is another type of data organization where the data is shown as ascending order. This makes it easier to look at the numbers, and you can easily put this data into graphs and find the mean, median, and mode. According to Adams et al. 2010, it states that rank order distribution is a list from the lowest to highest in a single column, making sure you use all scores. Rank order works when the number of participants is less than or equal to 20. This definition says that the number of participants has to be less than 20. This is because if there were more than 20 participants, the dataset would be too large. Frequency is another way of organizing your data, as well as grouped frequency distribution. Frequency shows how much of one thing occurs. According to Lavrakis 2008, it is a list of either qualitative or quantitative values that a variable takes in a dataset and the associated number of times each value occurs. As we can see in figure 1, I have organized the numbers into ascending order of resting BPM in gymnasts. And next to that column I have shown how many times that value came up within the dataset. Frequency can be carried out by going through the dataset and tallying up the scores, and then formatting the scores into a table such as figure 1. However, there is also grouped frequency distribution. This is where there is a range of values and the frequency is counted by looking at how many times a value within that group was present. For example, I have used the same data set as Figure 1, but have changed the formatting. In Figure 2, the value column has been put into groups that show a range of values that the numbers can fit into, and the frequency is showing how many times a value showed up within the group. This type of data organization works for datasets that can have 10 to 20 groups, so I think my dataset is a little bit too small. Outliers. Essentially, an outlier is any value that does not follow the same patterns as the other values in the dataset. There are several ways that you can treat outliers, and this is done by either leaving it alone and keeping them in the dataset. This could negatively impact the values such as the mean and the range of the data, as it doesn't accurately show the rest of the data. The other way is where you can discard any outliers. This means that they will not affect values such as the standard deviation or the range of the data. This is called trimming the data. Finally, winds arising is where you can change the outliers to the largest value that is not considered as an outlier. This means that it will still have an impact on the datasets and the values that you would get for range and mean, but is a lot less significant than having a much larger outlier. Presenting data. On this slide are several graphs that I've used. This is a line graph, scatter graph, a cluster graph, and a histogram.
Okay, I found this on the web, for this is a line graph.
In Figure 1 there is an example of a scatter graph, and the axis shows bicep on the skin fold caliper measured in millimeters, and the tricep on the skin fold caliper measured in millimeters. On a scatter graph, the dots represent two numerical values, and these values show a positive correlation. Although it was a weak positive correlation, it is shown by a trend line on the graph. According to Cleveland and McGill 1984, we define a scatter plot as a plot of two variables, x and y, measured independently to produce bivariate pairs, and displayed as individual points on a coordinate grid. The positive trend line means that if the bicep measurement is larger, it would mean the tricep measurement. The positive trend line means that if the bicep measurement is larger, so would the tricep measurement. Scatter graphs are used very often for presenting data, as they are easy to look at and we can clearly see if there is a correlation within the dataset. In Figure 1 I have used a scatter graph because it shows that there may be a relationship between the size of biceps and the size of triceps. Figure 2 shows a cluster chart. This is basically a chart, this is basically a bar chart, but if you have two different pieces of data that you need to observe, then this cluster chart has two different bars. According to Warren Davies, a cluster chart is like a bar chart, except it clusters several bars into a category and displays each cluster separately from the rest. In Figure 2 I have used a cluster chart because it is showing systolic blood pressure and diastolic blood pressure, but each of the two bars together are for each participant as well. This means that the chart is much easier to look at and you can see variations between different participants. Figure 3 shows a line graph, which is another common way of presenting your data. According to Halton 2019, a line graph, also known as a line plot or line chart, is a graph which uses lines to connect individual data points that display quantitative values over a specified time interval. I chose to use this graph in Figure 3 because the connection of the lines shows clear changes within the dataset, and it also shows where the two datasets might cross over. In Figure 3 shows a line graph where two different types of start were compared on their effects of a sprint speed whilst carrying out the sprint test. There were two different datasets for the flying sprint start and the static sprint start. An issue that I do have with the line graph is the fact that the points shown on the graph for each participant is harder to see on a graph, like a cluster graph, where it is clear that the bar is for each participant. I've also used a histogram for presenting data. A histogram is basically a bar chart of distribution of data, similar to my cluster chart, but there isn't any spaces between the bars. The reason that there aren't any spaces between the bars is that the chart is a continuous set of data. Figure 4 is a histogram for the sit-and-reach test, and it shows a continuous set of data. Although there are small gaps between these, it doesn't have a significant meaning, as it is still continuous data. Tables. Tables are another great way of presenting data. This is because they are very neat and easy to look at, which allows the researcher to be more clear in what each box is telling them. Tables are also very compact and organized, and can be ordered into color order or categorical order. Raw data can be put into these tables. The raw data would be placed in the appendix of your published research, where all of the raw data is shown. Then you can very easily separate more important data or single datasets into their own table, which can be placed in different sections of your published book, where the data is relevant for what you're saying. However, there are issues that come with using tables. If there are too many participants or there is too much data, then the table will be way too big. The table won't be able to fit into the appendix, and if you want it to fit, then you would have to separate the table. But this would make the table harder to look at. The table on this slideshow shows a raw data table for gymnastics participants and multiple measurements that were taken with each participant, using the same method for each. This sort of table is what would be put into your appendix. However, as highlighted earlier, this table is not the full table that is in our Excel documents. This is because the table in our Excel documents is too large, and I had to make it fit the slide. If I wanted to have the entire table, then I would have to make all of the font a lot smaller, and this would mean that the table would be much harder to look at.